We're going to be looking at how to administer network traffic. In the last class, we talked about the VNet creation. We talked about the, what are some of the things you need to know when you want to pair your network, when you want to extend your virtual network in Azure to the on-premises environment. And that's what we discussed the last time, where we discussed the VNet pairing. We talked a little about the VPN, where we discussed the point to site, the site to site, and the express route. Basically, I only talked about the gateway subnet, how you can actually create your hub and spoke network, how you can actually do a connection between the hub network and your on-premises environment, then how you can actually create a VNet pairing to allow the resources in different VNets to be able to talk to each other. So today, we are still going to be looking at networking. However, what we are going to be looking at today are resources, that we use to administer traffic. In our first class, I think during the fundamental class, we talked about the fact that there is a need maybe for JAM to, scale up or scale out their resources so that traffic coming into their application, the workload can actually cater for that traffic. And for us to do that, if we are scaling out, that means we are adding more resources. So when we say we scale out, we add maybe 2-3 virtual machines to be able to cater for the same traffic coming into that application at that particular time when there was lots of traffic, or when the traffic has actually increased. So because we want to have 2, 3, 4 workload or servers hosting that application, because they are going to be hosting this application, then how do we now determine where to send the user to? How do we determine, how the traffic will be spread across all these virtual machines hosting that particular application? So we need what we call a load balancer. So here we're going to talk about a load balancer, which is used to distribute traffic across workloads. Then we'll talk about application gateway. The application gateway is a layer 7 load balancer. The application gateway is also a load balancer. However, where this application gateway is functioning, the layer the application gateway is functioning is different from where the Azure load balancer functions. So we'll look at the difference between the load balancer itself and the application gateway. Then we'll talk about network watcher, which we want to monitor what is actually going on inside or within our network. So we'll talk about the network watcher. There are some other resources that we'll discuss, in this part, in this module, which are actually related to how we implement traffic management. So at the end of the day, you sort it out with the lab, which is the implementing traffic management lab. So let's talk about Azure Load Balancer. Within this part, we are going to talk about the load balancer solution. What does load balancer do? We'll talk about the public load balancer, the internal load balancer. I'm sure you guys now understand, the difference between the public, the internal, or the private. So if we are actually connecting to the internet, we want to load balance our traffic coming from the internet, then we'll be looking at having the public load balancer in there. If it's just something that's private to the organization, we'll talk about the internal or the private load balancer, and we'll talk about the SKUs, which are, what are different plans, what are different load balancer that you can actually implement. We'll talk about maybe the basic, the standard, the premium, and the like. Then how do we now direct this traffic to this workload? How do we direct this traffic to our application? So we need what we call a load balancer rule, and that's what we'll be talking about under create load balancer rule. Then the demonstration is maybe to configure a load balancer, then we do a recap. So these are different load balancer solution that you can choose from. Like I've actually explained, load balancer, what it does is to distribute traffic across the different backend workload that you've created. So when we talk about the workload, we are talking about the server that is hosting the application. So at the point where we have maybe our workload or the workload that is hosting our application, if we have that workload scale out, like add more resources to that particular workload so that they can so that our workload can cater for the application, the traffic coming into our application. Let's take for instance when Jumia started doing the Black Friday the first time, we noticed that their website started slowing down when more people were trying to take advantage of that Black Friday because they had maybe one or two or one server that was actually catering for the traffic that is actually coming or that was coming into that application at that particular time. Just because we want to cater for that traffic when we have maybe higher traffic than expected. So we need to have our workload scale out. And when we say scale out, we are adding additional, maybe virtual machine, additional server to actually help cater for that incoming traffic. And we talk about scalability, we talk about elasticity, where this is some of the features of cloud computing, where you have maybe an application that is hosted on your machine, and when there is the need for more machine to be able to host that application, then the application will be scalable in the sense that more virtual machine is created to host that application. So that's where the load balancer comes in. So the load balancer sits in front of those workloads because yes, we've created additional or automatically Azure has created additional workload for us. How do we not direct the traffic to the new workload that has been created? So we need what we call a load balancer. So a load balancer, sits in front of that particular workload and direct traffic, evenly to all the workloads. So if you have 3 workloads, if you have 100 requests coming in, so each of the workload will take maybe 33.3 requests, 33.3 requests, which is spread evenly among the workload. So it won't be like one particular workload is actually, a lot of traffic is directed to workload A, and workload B and C just have maybe 25% of the traffic, while the first one takes like 75%. So a load balancer, based on the rules we have created, senses, the number of traffic coming into the application and distribute, those traffic evenly. So these are different load balancer that we can choose from. We have the application gateway, majorly because we have what we call the WAF, which is the web application firewall. That is actually integrated with the application gateway, and that's why majority of the people tends to go with the application gateway. It actually distributes traffic, incoming traffic based on these protocols you can actually see here. So we can have inside an application gateway, we can configure, maybe we want to spread traffic across different workload, or we only have one server and we have different websites, on that server. So when the traffic is coming in, we want to spread, traffic, to those different parts on that particular server. So it depends on what you want to do. So application gateway, we can have it, private, public, depending on how you want to use it. And it comes with what we call the WAF. So you can use it for the Azure environment, for on-premises, for non-Azure environment, maybe AWS, Google GCP. The same thing goes with the front door. The only difference here is front door are global, just this is regional. Application gateway is regional, so you use it within particular region. So, but for front door, you have it regional, and that's what you can see. And front door has additional security, which is the network security group. So on the front door comes with an NSG. So you can actually, because it comes with its own network where you can actually set, NSG on the security on the subnet. Same thing with the load balancer. This is the application load balancer, and you can see the protocol is different because it doesn't work with the web. So you can see the TCP, the UDP, and this is also private. Regional, it is not global. So it works within a particular region. And it doesn't come with WAF, which is the web application firewall. And the last one is the traffic. You can see what the load balancer does. It balances inbound and outbound connection and requests to your application or server endpoint. So the last one is the traffic manager. This works more like a front door. However, this distributes services across different global Azure regions. So what this does is it sits very close to where your customers are actually accessing your application from. So I'm sure you guys have heard of CDN. CDN in the sense that, so if I host my application maybe in East US, and I have customers accessing my application from Nigeria, so it creates like a cache. And so instead of redirecting them to the East US, there will be like a cache that will sit in maybe one of the African region. So instead of directing them, so the first time a user access the application, you will notice that most of the time you will notice this. The first time you are accessing an application, it takes a while maybe to load, maybe 7 seconds, 10 seconds. And after then, if you try to reload that application, it reloads immediately. And that's what we call caching. So that's application maybe has been cached on your device, on your network or something like that. And that's actually like the same thing this guy does. So it distributes traffic across different services, within the region. So all these are just different load balancer solution you can choose from. All these guys, what they do is to take inbound traffic, and distribute it across the workload that is hosting your application. So the only difference here is what protocols do they work with? Do they work, are they global, or is it just regional based? What environment can you use this with? And so does any of these resource, do they come with maybe security option and the likes? And that's what you can see here. So we'll talk about how do we implement public load balancer. Like I've said, anything public is what you have actually exposed to the internet. It is not, we'll say an application is a public facing application because people, can access it from the internet. It is not within a particular application organization. So anyone with the URL, anyone with IP address can access, the application. So here you can see this is the internet, which is the cloud. We have users coming into user requests coming into the virtual network where the application is sitting. So the application is hosted on these 3 VMs, and these 3 VMs, they host the same application, and this is a load balancer. So once the traffic is coming in, the load balancer distributes the traffic evenly across all these virtual machines. And that's what we call, a load balancer. So you can see the public load balancer maps IP ports, to incoming traffic, across the private IP address of the virtual machine. So it applies what we call a load balancer rule to distribute traffic across the workload that is hosting that application. So just the same way we have, the public as the same way we have the private. But the only difference here is you can see this is happening within the particular network. There is nothing coming from the cloud. So this is a typical example of we have three machines that is hosting or different, it might be hosting different applications. However, these applications is actually all these applications are making use of maybe one particular SQL database. Because we want to distribute, it might even be the same application running in the same three workload. But so they also need to access, just like the Jamb environment, where when you access the application, the information you are accessing is not on the application. Rather, the information is actually saved in the database. So you need to hit the front end first. Then maybe if this is a microservice application, it talks to the backend. Then we have a connection between the backend and the database. So the database, whatever you've put in there, your name, maybe your Jamb ID, it needs to be checked with what you have in the database. So it extracts those information from the database. So your application don't store your information. The database does. So if there is a need for all this workload to access the database, now if we have just one database, that means there will be a lot of pressure since we have different machines that has been spin off for us in order to cater for the traffic coming into that application. So we need maybe the same set of numbers of database workload, because if all these machines are picking from the same SQL instance, that might be a problem. It might be slow, the responsiveness, the speed, it might be slow. So what we want to do is to, create additional database instance and split the traffic to those instances using our internal load balancer. So, and that is what this does. So it directs traffic only to resource within your virtual network, or the ones you use with a VPN. So it doesn't work with the internet. So, and that's why we call it, the internal load balancer. So these are different features. We talked about the fact that we have different SKUs. So depending on what you want to choose, depending on what you are trying to achieve. So this SKU is just like, when you want to buy your laptop, your computer system, you might tell the seller, okay, I want SSD, I want HDD, or I want premium SSD, something like that. So your hard drive is different from your SSD, and that's just like what we have as SKUs. So we have the basic, the standard. So under the standard, how many instances can you actually configure? So we have we can have up to 5,000 instances, so if you want to, so the backend pool is talking about the number of workload that is actually hosting that your application. So the number of machines that you can actually add, to that workload. So that's what we call the backend pool. So when we create an application and we want to load balance it, we need to create a pool of workload, a pool of the virtual machine hosting that application. And that's what we call the backend pool. So you can see the backend pool size. So we can see up to 5,000 instances. This is just 300 IP configuration, single available sets. The Earth probe, on what protocol can we check the health, of the backend pool, those machines that is hosting our application. How can we talk to them? How can we check if they are up and running? So on what protocol can we do that? And that is what this is saying. So I'm sure you guys know the HTTP, what the HTTPS, all stands for. At least even if you don't know, you know that at least um, the HTTP only gives you maybe access to the website without a secure route. And when you have the HTTPS, it's secure. It comes with an SSL. So the TCP is what we call the transmission control protocol. So this is just transmitting your data, your packets. So it's used for transporting packets. So it's just data. It's just that data. When you try to access an application, we say you are transmitting data. You are transmitting a packet. So the TCP, in case you see it anywhere or you are being asked for the full meaning, that's the meaning. So it's transmission control protocol. So this is just a protocol. So availability zone, in case you want to do replication, is not available in basic SKU. And these are some of the things you need to put into consideration before you choose the kind of SKU you want to go with. Then, can we have multiple front end? Yes, inbound only. That means, we cannot have inbound and outbound. So it have to be just one outbound, but, multiple inbound. So that means traffic can come in multiple ways, but can only go out in just, from one particular front end way. So secure by default, by default is open to the internet. So you need to now set up maybe an NSG to close it up. But by default, this is closed, unless you open up the NSG. So you need to create additional rule to open up the connection. So, but this one by default is open. SLA is not available. That means this guide can go down at any time. Microsoft is not giving any guarantee on this particular, basic SKU. But this one, Microsoft is saying this will always be available, at a rate of 99.99%. That means if you calculate this might be unavailable, I think, less than 7 hours in a year. So, which you will, rarely see. So this talks about how do you even create a load balancer rule, and this is what I've been talking about. So this is the client, which is you trying to access an application that sits there. So you will not have access to the IP address on this virtual machine. You only have access to the IP address here. And so we have this particular client eating this front-end IP, and this front-end IP is linked to the load balancer. So the load balancer checks all the traffic coming in here. Then from there, the load balancer can now, push in the traffic based on whatever we have in the backend pool. So if it checks the traffic and, let's say all these virtual machines are hosting the same application. So it checks the traffic and then, distribute the traffic evenly. So this load balancer that you are seeing here, so within the load balancer is where you have the rule, where you also have, the front-end IP also. So it might be public, it might be private, depending on where this client is actually accessing from, and depending on the kind of load balancer that you have actually set up. So it might be private, it might be internal. So that's what this does. Hold on. So it maps a front-end IP and post combination to the backend pool. Rules can be determined by NAT rules. What a NAT rules does is, so this is network address translation rule, explicitly attached to a VM to complete the path. So like I said, sometimes even your load balancer, it might not even be the same application. Or let's say it might be the same application, but whatever you are accessing is different. Let's say here we only have the information about the website. Then here we have images. Here we have videos. So it depends on what the user is trying to access. So the rule sends the user to the machine hosting that particular resource or that particular data. So if you just, test information, it will send the user to this virtual machine. If it's just images, it will send the user to this machine. And if it's video, send the user to this machine. So depending on the parts that you've created. So you can have, different parts, host, different resource or different data, and you can have them, maybe your machine hosting the same data. So it will just, so what the load balancer does is to check, based on the rules, whatever has been configured on this machine. So this guy is just telling us to create a load balancer, so let's see. So here, like I said, what we're going to do is to configure a load balancer. Now, so to do that, just the same way you've been creating different resource within your Azure portal, is the same way we create a load balancer. So you can go ahead to search for a load balancer here, by clicking on the create a resource, go to the network, search for load balancer. I'm just going to search here, load balancer. So see, you can choose, help me choose based on, the information. So different load balancer solutions. So you can see we have the layer 7. Like I've said, this is layer 4. It works on the network layer. This is layer 7. It works on the application layer. So here we have, so I'm going to choose, I'm going to create a load balancer here. So I'm picking this load balancer. Then I click on create a load balancer. So the same way, like I said, setting up the basic information. I'm going to pick the CICD. So I'm going to pick this guy. Just give it a random name. Okay, UK South. I'm fine with it. So this is, your SKU. What kind of SKU do you want to pick? Is it the standard? So this is recommended. This is even retiring soon. Do you want to create an internal load balancer, or do you want to create a public load balancer? And that's what this one is all about. So I'd rather just go with maybe the public load balancer. Do you want to create a regional? So you notice something when I selected the internal load balancer. This was grayed out in the sense that the internal load balancer cannot be global based, so it can only be regional. So if I select this, I can decide to choose, from the global or choose from the internal. So the next thing for me, maybe configure this. So I can just go ahead. So here you need to now create what will be your front end IP. So I can, let's pick up. So give it a name. I'm just giving it a random name. So here, the public IP, what machine do you want to assign with this? So these are all my machines. You can see it's trying to pick up the public IP of my machine. So the belief is the machines are the one hosting my application, so I can pick up from there. So so let's say I'm picking one of these. Okay, so what's happening? The IP address is already associated with a network interface. Yes, so I cannot do that. So I'm going to pick. I'm just going to create one. Yeah. So yeah, load balancer gateway. So I'm going to save this. So I created a new IP address already. Yeah, the backend pool is, like I said, these are the virtual machine that is hosting the application, or it might not, maybe it might not be the virtual machine. It might be, maybe if you have an application gateway, anything hosting your application, or even you can have it as Kubernetes service. So that's what you need to add here. So let's see. That's the net. This is the network where your backend pool is. So I'm going to pick this and pick the IP configuration. And this is the laptop. So this is the backend pool. Can just give it a name. Then I'll save this. Then the next thing for you is to configure the rules. How do you want to share, the traffic coming into your application? So if I create this, I can pick up the front end, the front end IP that I've created. Which pool do I want to send this to? Which is the pool where I added that virtual machine. So you can decide to add multiple machines. What port do you want to access? So if my machine if my application sits on port 80 on HTTP port, or if it sits on port 443, which is the one for HTTPS. So you need to select that. What port? This is the port where you want your user to come into. So you have to be HTTP or something. Then what port are you hosting your application? And that's what Earth probe is. You want, the load balancer to always check the earth of your virtual machine to be sure that that particular virtual machine can host or can take request. And that's what the Earth probe does. So I think it will be better. So you can see this is just how we create the load balancer. But let me make this easy. We can create an application gateway, which it makes things easy. You can see a lot of things on the application gateway. So if I go ahead to create the application gateway, so the application gateway does a lot of things. I'm going to show you guys. So you can play around. Just the same thing you can see, where I was trying to create my load balancer is what you will see on the application gateway. So you need to select the resource group where you want to deploy the application gateway. What would be the application gateway name? What region do you want to host this application gateway? Do you want to enable auto scaling in the sense that when multiple traffic is coming into that application, you want the application to gateway to help you create more instance, create more virtual machine that will host that application. And that's why I said it's always makes sense. So this is the minimum instance count that you will have, which is the one that will be hosting the application. And if there is a need for us, maybe we have a lot of traffic coming into the application, what I'm saying here is please application gateway create additional. You can go ahead to create additional 9 instance. So depending on the number of instance that you want to create, then will be the HTTP, the virtual network, where the maybe your instance will be sitting. Let's take it. What subnet? So that means all applications or all workload that is being created, all these 10 workload. So I want those workloads to be assigned an IP address from this particular network, from this particular subnet, from this particular network. So if we go ahead, then here we can choose if we want that application gateway or our workload to be accessed from the internet. And that's why we have public, private, and you can even go ahead to select both. If you're using this application internally and you're also using it, people can actually access it from the internet. Maybe there are different things they can access. So you want to put that into consideration. So let's say I'm picking, so this is already associated. I'm just going to create test. So, yep. Then the backend pool is where you have what workload is hosting your application. So here you can see we have different pools, different backend workload that you can select from. Do you want to use an IP address? You can put in the IP address of that virtual machine or whatever workload is hosting your application here. Then maybe the virtual machine here. So if I select this will expect me to pick up one of the virtual machine. Okay, the pool I selected, the network I selected, that there is no virtual machine within that particular network, and that's why. So what I can do is I can just put in the IP address of that machine. So the IP address now depends on if you're selecting maybe a public pool, a public application gateway, or the private. So if it's just public, I can put maybe the internal application, the internal virtual machine IP here. You understand? And if it's public, I can put maybe the public IP address here. So you give it a name. You can decide to add maybe a backend pool without a target. This will take up, that particular. Then you can go back, next time when you want to add another backend pool. So aside the virtual machine, if you have a virtual machine skill set, and that's what you can see here. If you are hosting your application on an app service, you can select an app service here. Let's see, do I have an app service in there? I'm not sure, but let's see. Okay, so let's say I'm hosting. So you can decide to select multiple. You can see there's a target already, so you can select multiple workload that is hosting the application. So it now depends on, this is where you now set up the rule. So let's say this backend pool is hosting this app service is hosting the backend of my application. This guy is hosting the front end of my application. So when you set up your rule, you want to decide where you send the traffic to when the user are trying to access your application. So just like you have here, so you can see, we'll configure what we call a list now. I will show you. So when the traffic is coming in, what we pick it up first, and that's the list now. Where would the the users try to eat or try to access when they are trying to access your application. So do you want to allow them on HTTPS or on HTTP? Is this application a multi-site? Let's say we have a microservice application where they have different host name for the front end as a different URL for the backend. Let's say the front end is or let's say the front end is google.com and the backend is app.google.com. So sometimes you might have access an application like that where when there is a need for you to now pay, you'll be redirected to another interface entirely. So yeah, that's what we call the multi-site. So if it's just a single site, all the application will be accessed from one particular URL, then it's fine. So this is just telling us, in case the application, we are not able to access the application due to bad gateway, we are not able to reach the server that is hosting that application, or we don't have the permission to access, what are some of where should the user be redirected to? And that's what we have here. This is the custom error page. The backend pool tells you the backend target, here, this is where we pick up, where do we want to redirect traffic to. So this is the pool where we have the app service. So that is what we call the app settings, where we set up the rules and the likes. So the path, this was the one I was explaining the other time, the path base, where you have a different path for your video, a different path for your audio, a different path for your images. So you can set up the path here. So depending on what you set here, that is the backend pool that you attach to, that particular. So you can see each of the parts. You can do that from here. In the application gateway, you can do something also by redirecting your application. Now, I'm sure you might have accessed or try to access a particular website, and you will see that after putting in the name of the application or the URL, just like this, if I try to do Teams Forest, you will see something .com. So I'm doing teamforest.com, but the original site is teamforest.net. So if I click this, so this is what we call the redirection. So you want to redirect traffic coming into that site to another URL completely. Let's say Access Bank and Diamond merge at some point. So anyone trying to access the Diamond website, we can do a redirection to say if you are trying to access, the Diamond website, please redirect the person to this website. So you can do that from here. External, so you put in the target URL here, so anyone, and in our listener, this is where we set, the URL that users will access. Like let's say I'm putting in diamond.com or diamondbank.com, and in our backend target, I will do a redirection and say access.com. You understand? So that's what we do with this. So this is how we set up the configuration of our load balancer, whatever you need to do in there. So I'm sure I'm still going to create a video, and in that video, I will take my time to create the backend pool. What are some of the things we need, and maybe we can have a test application and see how the traffic are being redirected. All right, so that's the end of that. So this is just talking about the application gateway. That's just a type of the load balancer, but this is actually a layer 7 load balancer, and that's why it works with the HTTPS protocol. And what does, just the same way we've actually explained what the internal and the public load balancer does, where users are coming from the internet. This is the browser the user is trying to access from. Then inside here, we have the front-end IP. I just showed you everything now. Your settings, everything. So it's the application gateway first, and the application gateway based on what you have as the listener. So you are eating the listener first, but based on what you have as the rule, your user will be redirected to the workload that is hosting that particular resource or data that you are trying to access. So what this does is it routes traffic to the pool of web servers based on the URL that is being requested. So you have set that inside your rule. So you can see we can make use of Azure virtual machine scale set, Azure App Service, or even your on-premises server. And that's why you have the IP. You can pick up the IP of your on-premises server and still use that as one of the backend workload. So we just explained this. So if you have a multi-site, like I said, let's say we have the backend URL, which is different from the front end, depending on what the user is trying to access. So if the user is trying to access the backend, so the user is redirected to the pool hosting the backend. And if the user is trying to access the front end, the user is redirected to the pool hosting the front end. And that's what we call the multi-site routing. But if we have the path base, it's just one URL but depending on what you want to access. So if it's video, if it's image, when you want to access an image, the user is redirected to the pool hosting the image. And if it's video, the user is redirected to the pool hosting the video. And that's what we call the path-based routing. So the last thing is for us to configure an application gateway and compare it with. Any question before we go ahead to the network watcher?
Okay, maybe to make it easier for us, if we probably think towards Jumia Black Friday
Yeah.
or Jam uh, registration, when you want to check your results, then
Yeah.
we can easily relate to that.
Yes,
So if
that's
only just think of Jumia
yeah,
Black
that's
Friday,
that's
we can
what's
easily.
happening, thank you. So let's say, I talked about the fact that when Jumia did their Black Friday the first time, their workload actually, went down. At some point, people were left hanging, they were not able to access the application. And what was going on at that particular time was they do not have access, or let's say their resource was not scalable. That means um, just one particular server was hosting the application. So there was no way to add additional server to host that particular application. And this is one of the reason, the cloud is playing a big part, or people are actually adopting, the cloud computing. You want to have your workload, you want to have it scalable. So when you have it, if now Jumia is, taking advantage of the application gateway and they try to, or they decide to have the Black Friday. So just like I was actually configuring the instance where you notice that you can have the minimum instance and the maximum instance. Let's say we have maximum instance of 10. So once people are trying to browse the Jumia web page, once the application senses that, oh, based on the rules that have been configured, let's say if this number of traffic, is coming into this application, please create additional workload. So once the application gateway senses that, oh, this traffic is kind of more than what the server can take, it will create additional, resource to cater for that application. That means at that time we might have 2, 3, 4, 5 virtual machine, you know, all running at that particular time to cater for that application. So that's just it. So at that particular time, we need a rule to say, or let's say we've even created 3 different servers. And that 3 different servers, we have one server. The front end is the jumia.com. However, for anyone buying, maybe when you're creating your website, you're doing anything, Jumia have another backend website. It might be maybe a subdomain website, let's say backend.jumia.com.ng. We will not see it, but they know. And majority of the website you see now, that's what they do. So there is a connection, and that's where there will be a connection between the backend and the front end. We don't see the connection. The only thing we are concerned about is, we want to access jumia.com. So when the traffic is coming in, or let's say Jumia have different, URL running the application, but you don't see it. Now, when the traffic is coming in into that jumia.com, we want to have it redirect to the pool that is hosting. So if you try to access some applications, let's say Jumia itself, depending on the location where you are, if you are accessing from Nigeria, you'll be redirected to jumia.com.ng. If you are accessing from Ghana, you'll be redirected to jumia.com.gh. If you are accessing from Egypt, I'm sure you might have noticed something like that. And the load balancer, the rules doing, their work, trying to redirect based on the rules that have been set up in that load balancer. So it might even be just one single website, regardless of where you are, but based on that particular thing going on at that particular time, you will not see it. You will not even see that there is a redirection, to another website or entirely, but it's happening. So the application gateway is, and that's what you can see here. So let's say we have this user is accessing from this particular guy is accessing from Nigeria. This one is accessing from UK. This one is from Ghana, So this pool is for people accessing from Ghana. This pool is for people accessing from UK. This pool is for people accessing from Nigeria. So once they come in, depending on the rule that we have here, they get redirected to the URL, based on that rule. Abiola, go ahead.
All right, sorry. I just want to summarize my understanding of what you said so that I can make sure that I'm on the right page. I'm going to use my Jumia for example now. So if Jumia had a cloud service, and when the Black Friday thing was on, a rule is set that once the traffic is getting higher, more resources, more virtual machines should be created, and then the load balancer. That's when the load balancer kicks in to distribute the traffic um, amongst the virtual machines that are created. Am I correct?
Yeah, sure. Does that make sense, everybody? Are you guys still lost?
We'll get along.
Are you guys still lost?
Sorry, do we have to create new virtual machine if we want to increase our load balancer? Do
So
we have to
the
create?
application gateway can do that for you. That's where the automation comes in. The automated, so when you're setting up the application gateway, like let me see, you can decide to have it manual, here, if you want to do auto scaling. Do you understand? But so if I set this to no, that means, I'm saying this is the normal instant count that I can have. So if there is a need for me to add additional resource, I have to do it manually. Do you understand? However, so I can say 10 instant counts, but at the time my application is running, I can only have, let's say I only have one workload running at that particular time. If we have more traffic coming into that application, then I have to manually add these virtual machines. So it doesn't make any sense. So that's, so why not enable auto scaling and the application gateway spin up your machine, for you without the need for your manual intervention. Do we understand?
Yes.
All right. Can you guys still hear me?
Hello, can you hear me?
Yes, I'm sure you can hear me now.
For this, can you
Yeah.
hear me, please?
Yes, I can hear you.
For this, for us to enable auto scaling, that it will increase the load balancer by itself. What of if there's no more traffic? Will it
It will go
reduce?
down.
Will
It
it
will
reduce?
discard. It
Okay.
will be discarded. That's why we have auto scale.
Okay.
So
Okay.
even if it increases to 10, that's what we are saying, that the minimum instance after discarding, please still keep one. That's what we're saying there. Do you understand? Yeah, so it will discard, and that's where the elasticity, the scalability comes in. So it stretches it when there is traffic and discard it when the traffic has, um, There is no more traffic at that particular time. Do you still have any question? I can still see your hand up.
No, no,
Uh,
no.
uh,
No, sorry, I'm
in
sorry.
the
I'm clear. Thank you.
in the availability zone, you chose zone 1, 2, 3. Is it automatic or you are the one that chose zone 1, 2, 3? Does that mean when it's being
I want to have
replicated?
multiple zones. Yeah,
All right,
multiple
all right.
zones. So you can decide to choose only zone 1, only zone two, maybe zone 1, zone 2, so depending on what replication plan you want to put in place. I'm sure we are good now. So the last one,
Yeah.
the last part is how do we configure network what's this? So sorry. So network traffic, as the name is it's just for us to be able to monitor what is actually happening within our network. We want to check the flow of traffic. We want to check, if there are any issues. If let's say we created our routing table, we are not able to, users are not able to get to our resource. You want to check so you can see the next up diagnosis. You can see how the traffic is flowing, and that's what we call the IP flow. You want to even visualize your network topology. So visualizing your network topology, it gives you access to be able to see, oh, there is a connection between this resource and this resource. There is no connection here. Yeah. So that's what. So this is just telling you what are some of the things that you can actually monitor with your network watcher. So you can have what we call the connection monitor to see if there is a connection between two resources. That's for the monitoring. The topology we talked about, where we have the hub and spoke. The hub and spoke network. Let's say we actually created a VNet pairing. We want to see if that connection really exists. We've created an NSG, which is the network, the network security group, and we feel like it's not working. The rules are not working effectively. So you can have what we call an NSG diagnostics. You can see it tells you the rules that you can actually create that will be effective as regards the NSG. If you're having issues with the VPN, you've created a VPN, let's say a point to site VPN, and user, regardless of where they are, when they are connected to your VPN, they should be able to access that particular virtual network, and you notice that that is not happening. So you can try to check using what we call a VPN troubleshooting, a VPN troubleshooter. So you can check the VPN troubleshoot, or you are trying to connect to. I will show you some of these ones. You are trying to connect to your virtual machine that you've created, and you notice that every time you try to connect to that virtual machine, you are getting an error. So you want to do a connection troubleshooting. So where it will tell you this is the reason why you are not able to connect to your virtual machine. Or you want to see the flow of traffic. So you want to verify from where to where will this traffic flows to. So we have the IP flow verify. Then we have the packet capture. You want to see where the packet will be routed to. The next up, if you have created your own routing table yourself. In the last class, we created our route table where I explained that, let's say you want to route from a virtual machine to the internet. So you can go on the route table and create the next up. The next up in that scenario is our internet. So that means the next up is, okay, once the traffic hits this particular resource, where will be the next destination for the traffic? And that's what the next up is talking about. then flow log, so you can see even when you do a verification to say this is how it goes, where is the log, so you can get the log, okay, the one that I've set up before, oh, this is how it is. And you can also analyze your traffic using the traffic analytics. So these are just how you can, based on the network watcher, some of the things you can see, some of those things we've talked about now. So we talk about the IP flow. What's the direction of the IP flow? So is it coming from, is it going to be inbound from local IP to a remote IP, or do you want to see? So if you try to do this inbound, from local to remote, we are denying the access, based on, and what is denying the access is, this security rule that we have set up. So you can check what will be the flow, how is this be connected, something like that. So you can do the next up. Just you can play around this, review the next up diagnosis, which we've talked about now. The traffic is coming into the application. Where will be the next up? Does it stays in the traffic? If the traffic, what they are trying to access is within the virtual machine, then we might not have, a next up. So yeah, it just eats the IP address, or we want to even set up a next up to say this will be the next IP that needs to be, once the traffic comes into, our source IP, what will be the destination? This is the maybe the local public IP. This will be the next place after it has hit this destination. Where do you want to route it to? Let's say this is the IP address we want to route it to, based on, and where have we created that particular nest up? We have created it on a route table, and this is the ID of the route table. So that's that. And the last one, I talked about the fact that you can actually visualize your network topology. So you can see what is the connection, from your VNet or from the internet to your virtual machine. So like I said, before you can actually create your virtual machine, there are some other resources that will be created alongside that virtual machine if you have not created them. And some of the resources are the VNet itself. So within the VNet, you have a subnet. You cannot have, your machine connected to your VNet without you having a subnet. So for every resource that you create, for every resource you attach to a virtual network, you need to have a subnet. So you can see you have 3 subnets here. Then if you are connecting a virtual machine doesn't just connect directly to a subnet. It uses what we call the NIC, which is the network interface card, and on the NIC, you can see within the subnet is where you have, the NIC, you can see the connection, and this is where, you have your virtual machine connected to. The public IP, if you have anyone, they are all on the NIC. And on the NIC is where we add or attach our network security group, which is the NSG. I told you for a virtual machine, you can actually implement your NSG on the NIC and also on the subnet. So you can visualize how that is actually connected. The same thing here, you can see we have um, a firewall, connected. This is the NSG front end. Here you can see a virtual machine also. If we have a firewall also, if we have an IP, then let's say we have a route table. So whatever you've created within your organization, in your subscription, within your resources, or within your resource groups, you can actually visualize how the connection to these resources are actually being made. And that brings us to the end of the class. So what you need to do here, the lab 6 is, you need to configure the load balancer, then configure an application gateway.